Alright, hell yeah. So we have general problems in physics, and this is IRODOV, and this is problem 1.31, you know what I mean? And this is part 3. What we're trying to do in this part is to get an equation for distance, the answer that they want, as a function of both height and alpha. I mean, I guess those are the only two things. So that's all our equation should have, but it should be pretty horrendous. So here we go. So, and we don't need to go over everything, but you know what I mean, we definitely have a ball that drops from some sort of height, and it drops on an inclined plane. The plane has a normal angle to the incline, and we know that this is the angle alpha, and that also means that this is alpha. The ball bounces elastically, so this is also alpha. So if we say, hey, what's the angle from the horizontal, you know what I mean, well, it's 90 minus 2 alpha, but we don't want to do that. We want to say, hey, this is the angle from the vertical, and the angle from the vertical is 2 times alpha. And so if we do that, I should have drawn this just a little bit higher, but we have a, if this is, I always do the dark arrow for my actual vector, so there you go. So this is going to be our V naught. We have a component, couple components, you know what I mean? You can do the components 2 different ways. Heck yeah. So this is Vy naught, and this is Vx naught. Cool. And Vy naught, you know what I mean? Hey, if my angle is 2 alpha, the sun is shining on the sine. So this is my sine component, and that's in the horizontal direction. So this is going to be V naught sine of 2 alpha. Cool. And then in the y, it's going to be the cosine component of 2 alpha. So we got V naught cosine 2 alpha. Alright, hell yeah. So we got a pretty good start. You know what I mean? We start with acceleration in the y. And now we're just going to use straight letters. I guess we'll have to introduce our next letter. That's going to be G. So G, you know what I mean, just to get a number on this is going to be negative 10 or 9.8, but it's going to be meters per second squared. But we just want to use the letter G. So just know that as we go through, G is a negative number. It's negative 10. Cool. Alright, so, and we're going to say that's equal to dvy dt, separate variables, and we get an equation for the velocity in the y. It is going to be gt plus the initial velocity in the y, v naught cosine 2 alpha. Cool, and then we say this is equal to dy dt, different, separate variables and integrate. So we have our function of y. You know what I mean? Just nice and clean. 1/2 gt squared, and this is the kinematic equation. We have 1/2 the acceleration of gravity times time squared plus the initial velocity in that direction, which is v naught cosine 2 alpha times t plus the initial position. But in both the y and the x, we're going to say, hey, this is the origin at 0. Cool. And then we do the same thing. We say acceleration in the x is 0. So our velocity in the x is just going to be our initial velocity in the x. V naught sine 2 alpha. And, oh yeah, obviously when we integrate this, it just goes g to the t. And then when t is 0, what's our velocity? You know what I mean? That's kind of what we do. Cool. And then you integrate again, and then this becomes plus a constant. When t is equal to 0, well, y is equal to 0, so our constant is equal to 0, just to show you there. Same thing here when we do the same thing, separate variables. This is dx dt, and integrate, we get v naught sine 2 alpha t. At t is equal to 0, what's our position? Well, it's at 0. So our constant of integration for this is 0. So hell yeah, so we got our equations for y and x. And this is a cool one because we really want to know the equation of the line. You know, if you do that, if you say, hey, this is y is equal to mx plus b, well, heck yeah, it goes through the origin, so b is 0, and it's just the slope times x. Heck yeah. And we see that at any point on this line, this is going to be my y value, and this is going to be my x value. You know what I mean? I mean, this is just a general point on the line. You know what I mean? Hey, let's go over some x, and then, well, I guess this point is going to be x minus y. You know what I mean? So, or just, I don't know. I don't think, I don't know. I hate negative signs, and it's like, well, how do you say that? Is it just, this is just the point x, y on the line. You know what I mean? Over x, and then but anyway, so I second guess myself on that because it's just like, holy hell. But we do know, but at least we do know this. We know that tangent of alpha is equal to this side divided by this side, you know, which is y divided by x. I mean, can I agree to that? Sure. And then we can say the slope is rise over run, but we got to go down y and then over x. So we got to go negative yx. Now I'm just second guessing myself. You know what I mean? It's like, why is that? I need to spend a whole video on, like, you know, do I just take a generic point xy? Is that what we're doing? You know what I mean? That we don't call this negative y just right off the bat. But okay, yeah. I mean, because if we're saying this is tangent, I mean, that's the thing. I love getting rid of the negative signs. But if we look at this as a triangle, you know, hey, we're always going to be in the positive direction. You know what I mean? So the tangent of this angle is assuming this is a positive number, like an absolute value of y, absolute value of x. But just in our case, our slope is going to be down y. So rise over run. We're not going up and then over. We're going down and over. So we got negative yx is our slope. So hell yeah. So the slope of our line is going to be this, and that's and we see that tangent alpha is equal to yx. So that means that negative tangent alpha is equal to negative yx, which is equal to m, our slope. So cool. So we say our slope is equal to negative tangent alpha, just to write it a bunch of times. Okay, so here's our equation. Our equation says y is equal to negative tangent alpha times x. Booyah. So there you go. Now this problem, it wants to know, like, when the ball is going to bounce one time. Oh, okay, hell yeah. And then we need to go back and figure out what the hell our initial velocity is based on the height. Because we have potential, actually it's just real easy, I don't want to waste any room. Potential energy at this point is mgh, and then it has to be equal to the kinetic energy, because we're going to set our datum for potential energy to be right there. So right here is 0 potential energy, but we know that energy cannot be created or destroyed as long as it doesn't leave the system. It doesn't when falling, and so we have kinetic energy is 1/2 mv squared. So these two things have to be equal, masses cancel, and you can see that velocity squared is just bring the 2 up, 2gh. So hell yeah, so we have velocity squared is 2gh if you see that, but definitely velocity naught is the square root of 2gh. So at the very end, you know what I mean, I ain't going to write this every single time, but this is the equation for v naught, you know what I mean, but we're just going to say, hey, initial velocity. I'm not going to write this every single time I'm writing v naught. That would get crazy. Alright, hell yeah. So we're on a roll, but this is where it gets complicated. We have to solve for t when we throw this in for y and this in for x. You know, it doesn't sound too challenging. And just to let you know, hey, if we do have tangent alpha, that's going to be the same thing as sine alpha, cosine alpha. But these are sine 2 alpha anyway, so they're not going to mix very well. And I don't know, you know what I mean? I guess I could. This is a double angle, you know what I mean? So I could see. Oh man, I'm going to take about 5 minutes, and look to see if there's any relationship with sine 2 alpha, and then write those relationships down, because as I go through there, they might be useful to like cancel stuff out. Who knows? Catch on the flip side. Alright, hell yeah. So I was just given this book, you know what I mean? Just tell people you're doing math problems, you know, people will just give you books. But this is Handbook of Engineering Fundamentals. This is Eschbach. But man, it's just so cool. It's better than the internet because, you know, just within 4 pages, you just have all of trigonometry. And, you know, and then there's basically every identity, you know, known to man that you would actually use. And so, man, it was really hard to find this double angle, but function of multiple angles. So we have sine 2 alpha, and they even do it as alpha. That's great. Is 2 sine alpha cosine alpha. Oh, so this is just going to be super helpful. You know what I mean? And so let's write that down. So we're going to have sine of 2 alpha is going to be 2 sine alpha cosine alpha. And then we have cosine 2 alpha. Well, it's a little bit different, but cosine 2 alpha is equal to, it's equal to a couple things. It's equal to 2 cosine squared alpha minus 1, or it's equal to 1 minus 2 sine squared alpha. You know what I mean? So, cool. Alright, yeah, that'll definitely come in handy. But this is better than the internet, because the internet you could look up double angles, and you might pretty easily get this, but you just won't get everything just within 4 pages. And it's just faster to flip to this than the internet. I really love this book. It's pretty cool. Alright, so let's get to it, because now the whole idea is just not to make any mistakes. Throw this into there, and then just solve for t. And then, but you know what I mean? Once we solve for t, we're going to get an equation that's a combination of g and velocity and cosine and alpha. And so we're going to have that equation as t, but then that's going to be the time. That's going to be the time of impact. You know what I mean? So that's what we're going to solve for, time of impact. Once we know that time, then we actually have to get... Not only do we have to get the xy coordinate, you know what I mean? Hey, once we get the xy coordinate of that point, because we'll throw this time into here to get the y coordinate, we'll throw time into there to get the x. And then once we know the x and y coordinate, then we even have to use Pythagorean's theorem, because we'll know this x value and we'll know the y value, but they want to know d. They want to know this horizontal, did I say that right? No. They want to know the hypotenuse. That's what I was thinking. You know what I mean? The actual distance between these 2 points. Not the Cartesianal, you know what I mean? You know, go over this way and down that way. So that's going to be d is equal to the square root of x squared plus y squared. And if you don't, this is fascinating. You can do like really complex stuff and then just totally forget about Pythagorean. You know what I mean? Obviously, a squared plus b squared is equal to c squared. You know what I mean? So don't mess that up. A squared plus b squared is equal to c squared. So for our problem, that's going to be x squared plus y squared is equal to d squared. You know what I mean? And I think people forget about this because it's also usually the equation of a circle. You know, if you're trying to map this equation out. But we just want it at one friggin' point. You know, I mean, we just want to find that d. And so there you go. All right, so yeah. So once we get the time value, we actually won't need to throw it in to solve for this xy point. We will need to throw it into this equation. So we'll get that time of impact, throw it into this, square it, throw it into that, square it, put it into this, and then take the square root of it. So yeah, we have our work cut out for us. All right, well, let's do it. So we have, I might just write small, you know what I mean, 1/2 gt squared plus velocity initial cosine 2 alpha t. And then I want to make my life a little bit easier. I mean, why don't we just set this all equal to 0? So we're going to go y is equal to, we're going to go y plus tangent alpha x is equal to 0. So that's, sorry I didn't write that. But that's what I'm going to do. So I'm going to say plus, and then I know tangent alpha, I already wrote it as sine, so I'm going to write it like that. So I'm going to go plus sine alpha cosine alpha, that's tangent. Okay, and it's on this side, and then we're going to multiply it by V naught. And check this out. If this is sine 2 alpha, can't we just do this? Hell yeah, we're going to use that identity. You know what I mean? So I'm going to box it up because we're going to use that identity. So we have, I'm going to bring this out in front. So yeah, let's do it. So this is, I don't need to. Or let's do it. So what the hell? Oh yeah, we're right here. So tangent alpha, and we already brought it to this side of the equation. We're going to set it equal to 0. I think you got that. All right, and then we got V naught. And now we have this. 2 sine alpha, cosine alpha. All right, we still got that t value. But now we can, oh, yeah, I don't know. Okay, so we can cross out a cosine alpha. Cool. And then we have a sine alpha squared. Booyah. All right, cool. And then we're going to set this equal to 0. Is that what we do? Yep. All right. And, oh, maybe this is easier than I thought. Because, you know what I mean, when you get something like this, you can't just factor out a t. Don't do that. You know what I mean? Watch some of the math videos like Red Pen, Blue Pen. They'll never do that. They'll factor out it. They'll factor out a t, but they just won't. They just won't bring the t to the other side and get rid of it. You know what I mean? Because this is going to be t, and then you just can we combine anything? Cosine 2 alpha. Oh, well maybe. Yeah. Because check this out. You know what I mean? This is going to be 2 V naught sine squared alpha. I'm trying to do as many steps as possible without mistakes, but I think writing more makes more mistakes. Okay, and then you have this t. So right here we can totally probably use this. You know what I mean? So and hey, you know what I mean? You have to don't forget about these. I forgot about those before. So let's do it. So you still have V naught t, and then I'm gonna put it. Hey, we're gonna and then multiply it by 2 cosine alpha, and then minus V naught t. So I just replaced this with that, and then definitely foiled the V naught. And sorry, I'm writing so small. We should probably take a little breather. Well, let's do that right now. So we have 1/2 gt, since we're factoring out a t. And, okay. And then so now we just have this thing. So it's plus V naught. And then we're already factoring out the t. I guess, yeah, okay. So we have V naught. I guess we have 2. I'm going to put the 2 out here. 2 V naught cosine squared alpha minus V naught. Okay, I think we're chill. Now we're going to, and then we're going to add it to 2 V naught sine squared alpha. And then we don't have a t, we already factored it out. Cool, so we factored out the t. But check this out. We have a cosine squared alpha and a sine squared alpha, and we're adding them together. So this just becomes 1. So I'm just going to do this and just say 1. And now that's it. You know, if you foiled this, let's go to the side. So we have 2 V naught, and then you would say we have a cosine squared alpha plus sine squared alpha. So this is equal to 1, and we're just left with 2 naught. We're not left with 4 naught, you know what I mean? Because these add up to 1. You know what I mean? This might be 0.5, and this might be 0.5. This might be, what's the other one it could be? I have no idea. You know, 0.25 and then 0.75, you know what I mean? Well, once those add up to 1, you're just left with 2 V naught. That's exactly what that says. And if can we do a bunch of steps at once? We have 2 V naught minus V naught. So hell yeah. So this thing is just V naught. So after all that, so this problem was cool, and it really hinged on looking up that double angle identity, you know what I mean, to instantly start canceling stuff. Hell yes. All right, so what you get here when you have a quadratic but you don't have like a plus a constant term, you don't have to use the quadratic equation. You factor out a t, and then what you say is like, now you have a, I'm sorry, this is equal to 0. So you have a product. It's like this. A times B is equal to 0. Well, if B is equal to 0, you know what I mean? Then check mark on reality. If A is equal to 0 and B is equal to something else, you know what I mean? Hey, this is still a check. We have a product. If either one of these is 0 at any moment and the other one is a number, it's still 0. So that's the principle here. And so I should rewrite it as just 1/2 GT plus V naught is equal to 0. Cool. And then you're just like, well, how does this equal 0 if it's like two positive things? But don't you remember, G is -10, so keep that in mind. All right, so now if we want to solve for T, that's what we're trying to solve for. And damn, like I tried to do this problem earlier, and it just wasn't this simple at all. So that was killer, double angle, you know what I mean? I guess going into tests, you definitely want to memorize those, you know what I mean? Because there could be some tricky problems that will use a double angle at you. All right, so okay, so should we do this in 1,000 steps? You know what I mean? Or just one. T is equal to, we're going to get the negative V naught to the other side. Then we're going to multiply by 2, and then we're going to divide by G. So that didn't look very pretty, but at least we're 100% accurate. Subtract the V naught, multiply by 2 upstairs, divide by G downstairs. So time of impact is equal to -2 V naught divided by G. Oh, hell yeah. That'd be wild if I could do this whole thing on a sheet of paper. Because now we're going to throw... Now we need to satisfy this equation. You know what I mean? So x squared is going to be V. So we're just going to square this. Square all terms. And do we want to use our double? You know what I mean? I don't think so. I don't know. I don't know. I really don't. I think we just leave it alone. But I'm not sure. Something in me says no. You should definitely use this because then it's a product and all these terms become squared. Hell yeah! So let's do it. So now we have the idea that x is V naught, and it's going to be times 2 sine alpha cosine alpha t. So that means that x squared is going to be this 2 squared. So we got 4. V naught squared. Cool. Sine squared alpha. And remember, this is just a product. You know what I mean? So if we got a times b times c times d times e and we're squaring it, that's the same thing as a squared. I mean, I'm a squared times b squared times c squared. I think you get it. So that's all we're doing. We're just squaring all those terms. And then t squared. Cool. Well, let's do that same thing with this. This one, you know what I mean, the y value, throwing in the double angle, we're going to get 1/2 gt squared. I think we get that part. And then this part, we're going to factor out a v naught t, and then we're going to do, I guess we could do any one of these, you know what I mean? But over here, well, I think this is the more normal. We already have a sine square. That's what I'm seeing. And then so, hey, let's just do a cosine. We also have a cosine, so that this gets you that sine, and then they cancel. It's like either or. You know what I mean? Either or. Just because you know, it's like how do you know it's either or? Well, let's take a moment and just use this tiny little piece. Is that we know that sine squared, you know, whatever, theta, plus cosine squared theta is equal to 1. Same thing with a squared plus b squared is equal to c squared. This is your c squared, and you can solve for anything. So if I want to solve for cosine, we say cosine squared theta is equal to 1 minus sine squared theta. Okay, so let's throw that in, and then we're going to get... so if we throw that in for... Yeah, so this would be 2 minus 2 sine theta, and then minus 1. So 2 minus 1 is just 1 minus 2 sine theta. See, you know what I mean? We did it in that amount of space. All right, so cool. So now we have, yeah, so I'm gonna stick with this. Oh, yeah. So we're gonna do this one. So we're gonna go, I should do this one first, but I guess who cares? So we're going to go plus 2v naught, what we do? Yeah, cosine. Cosine squared alpha minus, oh, and there should be a t, holy Toledo. I guess we'll put it right at the end. Minus, yeah, it's interesting when these are on both sides. Minus v naught t, because that's just the minus 1. Alright, hell yeah. So that's my y. And sorry I'm writing so small. It's just, you know, something fun to do, though. And in this one, nothing really cancels. So this sucks. Hey, yeah, that's fascinating. I mean, because we have to square this thing, and that just seems like kind of nightmarish. So yeah, let's just grab a new sheet of paper and see if we can. Yeah, I want to square it and see if I can start canceling stuff. That was the whole deal on this. So hell yeah. So we get 1/2 gt squared. But that's the thing. I could have made mistakes already. So even just doing this, you know, it might be a losing battle. You've probably already seen all the mistakes that I have made. But that's why we did the other video, so we have a check on reality. And hopefully we can find our mistakes and get this equation. But yeah, this is our y equation, and we want to square it. So this is what we want to do. We just want to do this. And I think that's the simplest thing to do, just write it again. So then we won't make any mistakes. Okay, hell yeah, let's get some battery juice and do this. Alright, so, yeah, holy hell, how many mistakes am I going to make here? Like, how do you even do this? You know what I mean? How do you foil, I mean, is it just this times this? Is that what we're doing? And then it's this times this? Does that make sense? It doesn't make sense to me, I guess, but that's the foil. And then you just add them all up. Yeah, I mean, sometimes in life you gotta go, this is how big you gotta go. Okay, let's do it. So we're gonna have 1/2 times 1/2. So we're gonna do these, that's obvious. You know what I mean? 1/4 g squared, t to the 4th. Cool. Now we're gonna do this. The half goes away, and the 2 goes away. So now we're gonna get v naught g. So plus v naught g. We're going to get t cubed. And then we're just going to have the rest. Cosine squared alpha. Cool. Alright, so now we're going to have minus 1/2 v naught g t cubed. I hope a lot of stuff cancels. Hey, we're doing pretty good. I mean, we just have, like, that was part 1. We just have 2 more parts. So, yeah, we're not doing too bad. Okay, the 1/2 and the 2 cancel. So we got, and then check on reality. Okay, we got our negative sign. When we do these, it's going to be positive. But this last term on this is going to be negative. Cool. So we'll do the first term, and we got plus v naught g. Now I'm just going to do the t term right here, t cubed. And then we have cosine squared alpha. Because even right now, it's like, well, aren't these the same? Okay, yeah, these are the same, so now we just have 2 of them. You know what I mean? So I'm just going to go do that, and then we got 2 of those. Cool. Alright, continue on. Now we got 4 of these. So we got plus 4 v naught squared. And then what's our t value? So it's only t squared on this one. And now we get something crazy. We get cosine squared times cosine squared. So we get cosine to the 4th. But I can always just write it as cosine squared. You know what I mean? Just know that. Just know that. You know, but I'm just going to write cosine to the 4th alpha for now. And I think we got all the terms. 4 v naught squared, t squared. Cool. Alright, now this is a negative term. So we got negative 2 v naught squared. Those are the first 2 I'm doing. Now checking the t's. Now we got t squared. Cool, don't we have that right here? Oh, whoa. Chill it out. And then we got, now we just have cosine squared. Cosine squared alpha. Alright, so these are hella similar. but they're a little bit different. You know what I mean? If we factored out everything, you'd have blah 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 factored out, and this would be cosine squared alpha minus 1. You know, so we can keep that in mind. You know what I mean? But you know what I mean? This doesn't have two cosines. You know, so I think you see it. Oh, and this was 4, and this was negative. So this would have to be 2 cosine squared alpha minus 1. Ah, but booyah, we know exactly what that is. Check this out. 2 cosine alpha minus 1. This whole thing, if we did that, so yeah, if we factored it out, we'd have blah, 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 and then it would just be that times cosine 2 alpha. So that would be a fun one. So we're already seeing the patterns, and hell yeah, you know, that's what it's all about. So we could do that one too. So keep that in mind. So these two, we could do that. And what the hell are we going to factor out after we do that? We're going to factor out just a 2, because you got to get this one. We're just going to factor, so this term right here would be 2v0 squared. Sometimes you just have to go for it and guess. Times t squared. So is that what we'd factor out? We'd factor out a 2v0, so this would be 2 cosine. Oh, whoa. And we'd factor out a cosine alpha. So let's do this. So I'm just going to write cosine alpha, but those are the terms. So let's rewrite this. So we would factor out a 2v0 squared t squared cosine alpha. And then we could change it to cosine 2 alpha. So that is what we could get out of both of those things. Hell yeah, we're on a roll. Alright, third one. So this is going to be all negative, but the last one's going to be positive. Okay, so we're going to do minus 2v0 squared. Oh, see, I'm already messing up. I hate negatives, you know what I mean? So anytime, yeah, negatives are on the page, do a little asterisk, we're making mistakes, but maybe doing that, I'm not going to make mistakes. So we got negative 2 v0 squared. We got 2 t's, t squared, I mean. And then we got cosine squared alpha. Hell yeah. Alright, so that was, and we're doing this all wrong. That was the second term anyway. What the hell? Should we go out of order? You know what I mean? I think we can all get it. You know what I mean? I don't want to rewrite everything. Obviously, I won't read it. I just go down. But anyway, so we're just going to do this. We're just going to go minus 1/2 v0 g t cubed. Okay, so see, we have a minus that. And then, hey, we got a minus that. So it looks like we got a minus a full one. So even right here, I'm just going to do that. Oh, yeah. So we have a minus a full one, and then we have a plus a full one. So right now, I can be like, hell yes, and hell yes. Those are gone. At least those are gone, but we still have one left. No. This one's tied up with this cosine. Now, so those are gone. Nice. All right, and then the last term. The last term is going to be plus v0 squared t squared. Cool. And hell yeah. All right, so we're doing pretty good. This is a cosine squared alpha. This is a cosine squared alpha. But this is only a t squared. This is a t cubed. Do we want to do that trick right here? I mean, we could rewrite it again. So this is going to be 2v0 squared t squared cosine alpha times cosine 2 alpha. And yeah, I think we should do that. Oh, but check this out. This is negative. These terms are the same. Negative 2 v0 squared t squared cosine 2 alpha. So we're gonna have minus 4 of these. And then yep. So it's gonna mess up our little equation just by a little bit. Damn it. But yeah, let's experiment with that. I mean, we don't have to. Oh, bummer. Oh, wait. Holy hell. No, these don't cancel. These don't cancel. You know, we're off by just a little. We're off by a 2 cosine. Cosine squared alpha on both those. So that's a bummer. All right. Yep. So yeah, it's like now what do you want to do? And so the things that drive, you know what I mean? Hey, let's say our time, you know, I think the time factor drives these. You know, time to the fourth, that's definitely a driving factor compared to time to the third compared to time squared, right? You know what I mean? That's kind of how these quadratics work. The first term is driving, the second term is second driver, and then the third term is like the least amount of driving. I don't know. I'm going to take a tiny little break. Oh, hell yeah. I love when I take just like micro breaks. I mean, I literally turn the camera off for about 10 seconds. And, okay, so what we did here was we made y squared, but we're going to add it to x squared. You know what I mean? So we have more stuff that we can cancel. So check this out. X squared, is right here. I'll just write it out. Is going, we got sine alpha, cosine alpha. Hell yeah. So x squared is going to be 4 v naught squared sine squared alpha cosine squared alpha times t squared. Okay, and this one we didn't have to write it like this either, which is probably not the best way to write it, because we can write it as just sine 2. Where is it? So x, so if we square x, yeah, I think we want to write it like this. It's just this squared. So v naught squared sine squared 2 alpha t squared. Because then if we get it like this, if we have something that is cosine, see how we got this as cosine 2. Didn't we get this as cosine 2 alpha? No, I guess not. Oh, no. Yeah, this should have turned into, oh, yeah, am I messing this up? No, we did. Yeah, it's cosine 2 alpha. But this is sine squared 2 alpha. Yeah, it'd be cool if those cancel. If we get a sine squared to cancel with that. And we're pretty close. See, this is a v naught squared t squared. So yeah, I'm going to focus in on this equation and see if we can convert this to a cosine squared alpha. I mean cosine squared 2 alpha. Because if we could do that, oh, yeah. And then here's the bummer. You know what I mean? Because, like, why the hell did we even use this to even simplify it in the first place? We used it to simplify here, which made our life pretty easy. We got a t value of just negative 2 v naught g, and then we threw that in. And did we even do that? Oh, I feel like we didn't even do that. We still have our t values everywhere. Holy hell. I never even thought of that. That, you know what I mean? Yeah, what a nightmare. It's just like, yeah, when should I have thrown this? I should have done that right away. You know what I mean? Because once we did that right away, then we could have... And so I think the thing to do is just keep these as sine 2 alpha and then this as cosine 2 alpha. Well, we're still going to have this tangent as sine alpha divided by cosine alpha. So there's not much we can do there either. You know what I mean? You could do, I'm gonna, you could do this, since we do have these. Sine... this, you can rearrange for sine alpha here and say that sine alpha is equal to 1/2 sine 2 alpha divided by, oh, that's not going to help, cosine alpha. Yeah, you're still going to have a cosine alpha. But no, let's check this out. So we're just solving for sine alpha here. And that's going to be, the 2 goes downstairs, sine 2 alpha divided by 2, and then the cosine alpha goes downstairs. We're trying to throw it into this equation. And then you have cosine alpha. No, see, this doesn't have a cosine alpha in it. Yep. See, yeah, you can't do anything there. I'm sorry I did that. So now I just don't even know where to go. You know what I mean? So should I throw in? Well, yeah, let's do it. So we're gonna. So this T impact is -2 V naught G. So time is going to be -2 V naught divided by G. So I'm really glad I did that because it really simplified it. So now this x squared term is going to be. The 2 gets squared, so t squared is going to be 4 v naught squared divided by g squared. And if we do it right here, this whole thing becomes 4 v naught to the 4th divided by g squared, and then just sine 2 alpha. Okay, hell yeah. So let's at least do this with this, you know what I mean? Just to, we already got it up here. So t to the 4th is going to be 16 v naught to the 4th divided by g to the 4th. Cool. So if we throw that in, we're going to have 8, because 16 divided by 2 is 8. We're going to have g3 up top, and then v naught to the 4th. So we got y squared is equal to 8 v naught to the 4th divided by g to the 3, and that one's good to go. Okay, now we're going to add it to, if we throw in t for this one, we actually get negative, so we get -4 v naught squared divided by g, and we get cosine 2 alpha. Hell yeah. What the hell are we doing, man? I apologize. Yeah, I was like, why isn't that working out at all? So no, we're doing these. So here's our next term. Sorry about that. So we got plus, and we got a t cubed. So this is just, so we haven't done that one. You know what I mean? So t cubed is just going to be multiplying these together. So we're still going to have a negative. You know what I mean? So we have -8. -8, we have v naught cubed divided by g cubed. All right, that wasn't too hard. Okay, so here's the next term. So we have a v naught times a v naught, so that's going to be v naught cubed. We have a g upstairs, 2g, so we're going to have divided by g squared downstairs. We have -8, so here we go. So we got -8 v naught, and we're going to have to the 4th. Did I say cubed? I think I said cube, but v naught to the 4th is just to the 4th. Cool. And then divided by g squared. Hell yeah. And that's because we threw in the t time of impact cubed. Okay, we did that. So now we just multiply by cosine 2 alpha. All right, hell yeah. And it's this term that I just don't know. I want to do that like absolutely last, because I don't know if I want to combine it with... well, you know, no, we already, yeah, I think we need to make a decision on this. Well, let's at least get this term, and so we're going to add it to v naught squared. So we have 4 plus 4 v naught to the 4th divided by g squared. All right, even like right here, does anything cancel? Not really. Okay. Yeah, so it's this. I mean, these two terms are identical, so we're going to have so we can factor out a 4 and a v naught squared and a t squared, and now we're just going to have cosine 4 alpha. Cosine to the 4th alpha. And then these are adding to be 4 v naught t squared. V naught squared t squared cosine. So we just have minus cosine 2 alpha. So that's all that we have. And then I think I want to write this this one, because if we do have something like 2 cosine alpha squared minus 1, this can equal cosine 2 alpha if we ever get to that step, because right here you can factor out a, and I should have done that, let's, sorry for writing so small, but we got v naught t squared, factor out a cosine 2 alpha, and now we just have cosine 2 alpha minus 1. But we don't have this. Oh, that's sweet. So we can, yeah, it was just nice to combine them, and we got but now we're going to have to, and yeah, we just don't have this. We have. I don't know how you would actually. I'm not smart enough. I don't know how you get like a subscript there of 2 and don't mess that one up. Like, I just feel like that's impossible. Oh, but holy hell, you know what I mean? It's like you're not seeing. Pythagorean theorem comes up all the time, and it comes up in weird ways, even when you're dealing with like trigonometry. It's just like, this is not the time you're thinking Pythagorean's theorem. But we have sine squared alpha plus cosine squared alpha is equal to 1, and so so this term right here. So this is so we have. So let's say we did cosine squared alpha minus 1. Okay, let's get that. Cosine squared alpha minus 1, and then it's going to equal to negative sine squared alpha. So hopefully I didn't mess that up. And see, I'm messing it up anyway, because this, no, we got the negative. At least we have the negative on here. And this is the one that's the positive. Okay, so sweet. So yes, so this term, this whole term right here can get replaced with negative sine squared alpha. So then we would have a cosine squared alpha times sine squared alpha. And yeah, that's just fascinating. So I guess I'm just going to write this one right here. We're going to have negative v naught squared t squared cosine squared alpha sine squared alpha, and I'm going to look up what that represents, you know what I mean? But that's it, so we did it. That's it. And if we want to throw in the t squared, even just right now before we figure out what the hell that is, because it won't matter. So here's t squared. So we're going to have negative 14 v naught to the 4th divided by g squared cosine squared alpha sine squared alpha. All right, so hell yeah. Oh, and I put it in the perfect spot. I really didn't need to even do that. So hell yeah. So we did it. So this is our first term. This is our second term. This is our last term. And then these are the 3 terms that we just combined to do that, and I definitely need a break. Alright, hell yeah. So we're back, and what I realized is this is just so dumb. Cosine squared alpha, sine squared alpha, because, we have this relationship. So if we want to just say sine squared alpha, well, that's just 1 minus cosine squared alpha, and then we would throw it in, and then we're just back to kind of where we started. You know what I mean? So what we're going to do is, I thought it was really cool to identify that this is going to be, 2 cosine squared alpha minus 1. We can factor that out, and then that is our identity for cosine 2 alpha is, 2 cosine squared alpha minus 1 is equal to cosine 2 alpha. And damn it, I'm still in the same position. We're still not. I don't think we're gonna get a cosine squared 2 alpha to cancel that. That's all I want to do. I thought that would just be really cool. But yeah, I don't think we can do that. Maybe let's look up just another half angle, like all the half angle identities, just in case we're not missing one. Yeah, just those two. Alright, so I don't know. I mean, do I want to? I don't even know if this is right. You know, we could have made a lot of mistakes anyway. But at least let's go a second direction, and we'll do it. So we're gonna say this is going to be plus, and then we have it. So this we're gonna throw in a t squared in there. So we're gonna have 8 v naught to the 4th divided by g2. So plus 8. V naught to the 4th divided by g2, and now we have cosine alpha. Cosine, is that what that gave us? Oh yeah, because we had to factor out a cosine alpha, but now we multiply by cosine 2 alpha. Cool. I wish I didn't do it like that. But yeah, there's our term there. And then we'd still have to subtract it. We would still have to subtract this term. And this is going to be minus. And we have a t squared. So this is going to be minus 8. Hell yeah, and this might subtract with something. For sure. Oh, this is going to be super cool. So minus 8 v naught to the 4th divided by g squared. Okay, now cosine squared alpha. Hell yeah! Oh well, it doesn't cancel. And let's just check on reality. This was the first term. We came to here. I think this was the second term. We had negative 8 v naught to the 4th divided by g2 cosine squared alpha. So now we're just going to have, these are going to be negative 16, you know what I mean, blah, 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 cosine squared alpha. But I mean, so now, and we still haven't added, this is my y squared, this is my x squared, we still got to add these together. And I thought by adding them together, you know, one of this would cancel out somewhere. But it doesn't seem to. Oh, because that's the other thing. We could actually, this is a sine squared, yeah. Well, look at that. Well, this is sine squared 2 alpha. Yeah, I don't know what we would do. No, what was our other half angle right over here? Oh, yeah. Our other half angle was sine alpha cosine alpha. We have sine squared alpha cosine alpha. Oh, well, no, duh. I mean, okay, so let's say we stuck with this. There it is, you know what I mean? This right here is the same thing as saying sine alpha cosine alpha. Well, we just have that twice, you know what I mean? So we would just have sine alpha cosine alpha. That's all this is saying. So cool. And then as long as we have a 2, so this becomes negative 8, and then we would have a 2, and then this, one of these would become sine 2 alpha. But still, I just don't think that's very useful, because this is a sine squared 2 alpha. Oh, yeah. And unless I did my foiling completely wrong, yeah, you're just gonna have that. Yeah, we definitely have this term. Oh, interesting. Cause yeah, where did this come from? Sine squared alpha cosine squared alpha. I think that's where we just got that term. Yeah, let's revisit that one just so we don't make any mistakes. So we said that V naught was sine 2L. Oh, just right off the bat, holy hell! Because do we have a like what do we have in our y that we were saying? Yeah, we don't have any cosine squared 2 alphas. That's for sure. We don't. Yeah, we just don't have that cosine squared 2 alphas. To cancel the sine squared 2 alpha. So so that's where we used this theorem, the half angle, and then we get this to be 2v naught sine alpha cosine alpha. So that's what we do right here. So this, and then we square it, sine alpha cosine alpha becomes sine squared alpha cosine squared alpha. And then we multiply by t. Yeah, we haven't done this one. And then this is going to be, let's do this one. So this is 16 v naught to the 4th divided by g squared. And now we have sine squared alpha cosine squared alpha. Okay, and check this out. Did I mess up? This is negative 14 because that would be real dumb of me if it's 16, because then these would just instantly cancel out, and that's what that was what I was going for. So that's probably an error. Negative 14. Where the hell did I even get that? Yeah. So here's the error. So we have t squared is 4 times 4. You probably saw that one. Yeah. So 4 times 4 is negative 16. V naught to the 4th. Finally, hell yeah. So finally, it was this, the x squared. So yeah, when we have the equation that says d is equal to the square root of x squared plus y squared, hell yeah, y squared is hella complex, but the x squared cancels out one of the y squareds. And that's kind of what we expect for doing similar problems. So hell yeah, so that term cancels and that term cancels. Now what strategy did we use to get down to here? I think we actually just combined both of those terms. You know what I mean? We combined all the terms. And isn't that what we did? I honestly, I kind of just forget now. Like, we boxed that in and we were really excited. That's why there's one good reason to actually make videos on your own video. You could just go back and watch. But now, let's see. Because now, do I have too many terms in here? That's the only thing I need to have a check on reality. So this term is set. This term is set. And then, yeah, what about this one? Yeah, I think this was just probably like a mistake. And, No. Holy hell. No. This term stays. I apologize. I shouldn't have done that because this term was right here. I went this term, and then the easy term. So there you go. Those are the 3 easy ones. So we got that one, and that one. And I really apologize. I scribbled that out just for my own sake. And then we had these. We combined them. They were going to be 4. We could factor out a 4 v naught t squared and then t squared, and then we would just have and a cosine, so we could factor that out, and then we would have a cosine 2 alpha minus 1, but we didn't go that route. That's the weird thing about why I'm freaking out about this one. Alright, I'm just going to grab another sheet of paper, and I might as well just do that right here. I mean, this whole deal is just to, you know. But yeah, definitely getting overwhelmed. Right, hell yeah. So we're back. We took no break, but we're just going to do it. So, yeah, let's do these. So this term is a v naught squared t squared cosine 4 alpha. Now we minus 4 v naught squared t squared cosine squared alpha. And Yeah, I'm just confused about where these two terms came from. Like I just totally forgot like what the hell we were doing. But I think we're up to speed on those three, and then it was just like how do we proceed with those two? And then I'm just like, well, how did I get that? You know what I mean? How do I work backwards? Oh, yeah, so I did. No, duh. Okay, I got it. Yeah. So I got it to, I did not use this. You know, I didn't use that, but okay. But we did combine these two. And then we factored out the, yeah, and then we get something like cosine squared minus 1. And then we see that that's the, you know what I mean? So we have sine alpha squared plus cosine squared alpha is equal to 1. Pythagorean theorem is just like the first one to forget, and it's the most useful one to always use. Okay, so we can factor out a 4v naught squared and a t squared and a cosine squared alpha. And if we do that, we're left with a cosine squared alpha minus 1. So I think we see that. And if we go over here and we say cosine squared alpha minus, I just totally forgot about that. This is negative sine squared alpha. So now this just becomes negative 4v naught squared t squared. And I'll do the sine first. Sine squared alpha cosine squared alpha. That's what this becomes. And we were so excited because that's what we subtract. This is a negative one, and then this is the positive one. So even right here, we don't even have to go through the strokes. This is 4v naught squared t squared sine squared alpha cosine squared alpha. But if we did go through the strokes, we know that t squared is 4v naught squared g squared. You know what I mean? So then we get negative 16 v naught to the fourth divided by g squared sine squared alpha cosine squared alpha. And you can see that that is equal to this. Then up here, we're going to have a positive 16 v naught squared g squared sine squared alpha cosine squared alpha. Hell yeah. So now these three terms, I'm just going to do that and that, cancel this x squared term. Booyah. So the only things that we're now left with is this first term, this term, and the last term. And might as well just use, yeah, a fresh sheet. So we have in the first term, you know, what was our t to the 4? So that's going to be 4. Oh, did I even mess this up? Because this is, yeah, why am I messing stuff up? But yeah, this is a good place to check errors. So yeah, 1/4 times 16 is going to be 4 v naught to the fourth divided by g squared. Oh, that's not that term anyway. Unless I just royally messed up. Yeah, the first term on yeah, that's so fascinating. So yeah, let's do the first term. So the first term is going to be 4 v naught to the 4. But that's the thing. That was the whole issue. Is just like I don't know why my mind just makes very small little like, you know, your mind will do addition and subtraction before it does multiplication and division for some reason. Okay, so we got that, and then we got divided by g squared. And yeah, so that term's covered. 4 v naught to the fourth divided by g squared. Cool. Now we're going to go add it to this term. This is going to be negative 8. Yeah, it's this term, but we'll just double check it. So we have negative 8 v naught to the fourth divided by g squared. I mean, hell yeah. And then we got cosine squared alpha. Okay, that's what we got. These cancel out. These canceled, or yeah, these added up and canceled out with that term. So now we're just left with this, and we got plus. So this is going to be 4 v naught to the fourth divided by g squared. plus 4v naught to the fourth divided by g squared. And is that it? Yeah, the 4v naught to the fourth divided by g squared. I really honestly don't know how I totally munched that first one. That was ridiculous. Yep, I apologize about that. Maybe I was just multiplying a different term, and I saw t to the third. Yeah, if I think that's, well, that wouldn't make sense anyway. Yeah, I royally messed this one up. I mean, this would have had to been g to the 5 to get a g3 down there. You know what I mean? So I'm just going to do that and apologize about that one. And then, what about this one? Did we say that one just cancels or something? Yes, we already saw that, yeah, oh. Well, these don't cancel. They have a cosine squared. Holy hell. Okay, my bad. Yeah, see, I didn't see that. So yeah, we definitely made mistakes on that. So this is going to be 2v naught g to the t to the 3 cosine 2 alpha, but it does not cancel with these. Okay, so now we need to go back to the drawing board, kind of, you know, like 100%. All right, yeah, let's do this. All right, so what terms do we have? So we have 1/4 g squared t to the fourth. We're going to have 2 of these plus 2v naught g t cubed, and this is cosine 2 alpha. Now we have this is going to be minus v naught g t to the 3. And then we got plus v naught squared t squared. I think everything else cancels because, I mean, these were the things that majorly canceled with the x squared. X squared cancels all those 3 terms. So now we're left with 1, 2, well, I mean, basically we have 1, 2, 3, 4 terms. So we cancel. So when we did this, we had 1, 2, 3, 4, 5, 6, 7, 8, 9 terms. And now we got to cancel 1, 2, 3 of those. So we should have 6. So we have 1, 2, and then 1, 2, and then 3, 4, 5, 6. So we'll have 3 terms. We'll have 1, 2, and then 3, 4 terms, or 4 terms. Yeah, sorry about that. So yeah, so 1, 2, 3, 4, because we have 1, 2, 3, 4, 5, 6. So we got to cancel 3. Holy hell! So we got 1, 2, 3, 4 terms. So now we can use these little tricks. And what's our t to the fourth right here? So yeah, we're gonna have 4 v naught to the fourth divided by g squared plus, this is a t cubed, so it's minus, sorry about that. Oh, and then, okay, yeah, now this is going to be minus 16, this is a new term that we haven't done yet, to the fourth divided by g squared, but we'd have cosine 2 alpha. Now we have minus t to the t cubed, which is another minus, so we're going to have plus 8 v naught to the fourth divided by g squared. Cool. And now we have v naught, we got a t squared. Cool. So this just becomes 4 v naught to the fourth divided by g squared. All the v naught should be to the fourth. Hell yeah. And look at that. So we have a g squared all over, and we have 4 plus 4. So that's good. These two are going to be 8. And damn it, did I mess up a negative on that? No, because this one became positive. Okay, fair enough. Oh yeah. And it's really cool because we're going to take, at the end of it, we're going to take the square root of everything. And if we want a hell of a nice answer, You know what I mean? It's nice to have like 16s. Well, no, that's not going to be 16. Oh, no, yeah, because we got 4 plus 4 plus 8. So cool. So we're going to have 16 v naught squared divided by g squared minus 16 v naught to the 4th divided by g squared cosine 2 alpha. Hell yeah. And then we're going to take the square root of that. And, whoa. I mean, I really can't, you know what I mean? But that's going to be my d. And I've done this problem where if we throw in 20, we should get a check on reality. If we throw in 20 for that and 30 for this, we should get a check on reality. So let's do it. We're going to do the square root. I want to do this piecewise. Well, we can even factor it out. So we can say d is the square root of 16. And see, why am I making mistakes? You know what I mean? This is v to the 4th. Yeah, that has never changed. So yeah, we can totally factor out the 16, the v to the 4th, and now we can factor out the g squared out of this, and we're going to have 1 minus cosine squared. Holy hell. Like, I hope I'm not just losing my brain and this is going to be a really good video. Because right here, don't forget about Pythagorean theorem. Sine alpha squared plus cosine squared alpha is equal to 1. And so that means that 1 minus cosine squared alpha is equal to sine squared alpha. Man, this is so cool. Like, I'm just, like, there's no way that I would have ever done this in college. You know what I mean? This is just stuff that is just like, yeah, I just want to do it. So I'm going to try, make mistakes. But no, it's like I'm definitely finding like a way to learn how to learn. You know what I mean? I would never start a problem like this. There's no check on reality. You know what I mean? So hell yeah. So now this is going to be sine squared theta. So I'm just going to do this. And we got sine squared, alpha. This is sine squared alpha. And so hell yeah. So d is, and if you did this, you know what I mean, this is the same thing as the square root of 16 times the square root of v naught to the 4th times the square root of sine alpha squared, you know what I mean, if you do it like that, and then divided by the square root of g squared. So if you don't know how to get things in and out of the square root, definitely set it up like this, because this just becomes 4 v naught squared sine alpha divided by g, and that is our distance. So there you go. So our distance is going to be 4 v naught squared sine alpha divided by g. And like, you know, I'll let you know if I ever look at solutions. You know what I mean? Hell no. Like I'm in the mode of not looking at solutions, but I'm sure there are some problems, especially if you tell me to do a video on solutions. Be like, hey, check out this solution. It makes no sense to me. Do it in your way and make it make sense. Like, I would love to do that. And I think you can get very good at looking at solutions, but you have to be smart enough to look at the solutions and not just lose your friggin' mind, because you'll just be like, oh, I feel like I forgot everything, because people will do it in slightly different ways, and if they're not explaining it to you, you just have no idea what they've done. But I mean, no reason to pat myself on the back yet, because we don't know if this... So sine of 30 is 0.5, so we have 0.5, and we did where this was 20, so 20 squared is 400. So we have 400, and then g was negative, because even right here, yeah, well, g squared, so this is the absolute value of g. It has to be. It's, you already squared it, you know what I mean? So that is, that'll be fairly interesting. It has to be, I guess, yeah, how does this work out? Is d the plus or minus the square root? Is that kind of how it works out? Because if g is negative, obviously the distance isn't like a negative distance. But anyway, so this is going to be 10, and you're going to have 1600. So you're going to have 160, we already did it, and then times, so you're going to have 80. Hell yeah, and that's the answer. That was the answer. So yeah. The answer that I got was just really close to 80. I actually didn't solve it 100%. I just used my guessing skills, so we made that video. So hell yeah. So we got 4 times 10 squared sine of 30 divided by 10. And no, that didn't work out. Wait, what? Oh yeah, my velocity, my input velocity from that last problem was 20. Sorry about that. So we got 4 times 20. Yeah, it's so fascinating. You just make mistakes everywhere. But that's the deal. It's like this whole video is just like, well, we already did it. So it's like there's no way we can get to this point and not make a mistake. And 80 meters was the check on reality. That's the problem that I did of like how not. That video is how not to make mistakes. So maybe I'll link it below in the description. Probably not. You can look it up. This was part 2. Or no, this was like part 3 of this problem. At first, I just did it real fast, 15 minutes, just to try to get some sort of equation that was just hella and say, well, you know, I mean, you input it. It's really ridiculously huge, but who cares? It still should be a check on reality. But then with trigonometry, hell yeah, you can just really simplify this down. Where basically everything cancels. It's just one of those problems where everything cancels. So it's pretty sweet. And we have our equation for distance. You know what I mean? And this is an equation for distance with any. Whoa. Yeah. I totally forgot that we haven't set it up with energy. So let's throw some more time on the clock. And this will be the last thing we do. You know what I mean? So. We set our initial problem, you know, due to energy, due to the height, that our velocity initial is the square root of 2gh, and then we just said our distance is equal to, and I'm just going to leave this g as you know, I'm not going to do a minus, but I guess we could, yeah, I guess, yeah, so d is going to be minus v 4 naught squared sine alpha divided by g. And then g obviously is a negative number, negative 10. And then so we're gonna throw in this. So hey, we got a v naught squared. So v naught squared is just 2gh. And now we throw it in. So now we have our distance d is equal to, oh, and check it out, gravity cancels. Oh, hell yeah. So yeah, this is so cool. We don't even have to deal with that. We don't have to deal with the negative signs. So let's write it a couple times, because we have I mean, basically we have 4 times 2gh sine alpha divided by g. G's cancel. And we got 4 times 2. So hell yeah. So equation for distance. And you can write it like this. Such a fun way to do it. Equation for distance as a function of height and as a function of alpha. And that's it. Well, what a very beautiful equation, man. But yeah, we have 8 times height, 8 height sine, and I could be hella wrong. I haven't looked at the solutions. This might be the dumbest answer that you've ever gotten. So I'm going to spend tomorrow kind of running through a couple scenarios, and for the height that we chose was 20 meters, and that turned out to be, so we got 8 times 20 times sine of 30, and obviously that's 80. So cool. So there's our equation. So after all that, we get something very simple. The distance as a function of height, and then there's our problem. You know, if you want to read it again. Distance is a function of height and alpha for that ball bouncing is 8 times the height sine of alpha. So that's going to be the distance away. And let's do it. What if it was horizontal? I mean, we can actually do a check on reality. If sine of 0, oh, well, yeah, it's not going to go any distance. It's just going to bounce up and down in the same spot. So yeah, that's not a very good check on reality. Anyway, so I'm going to spend tomorrow going over some examples and seeing if they pan out. But anyway, so I'm done with this video, and man, that was cool. We stuck with it, and we learned something about double angles. You know what I mean? And definitely Pythagorean theorem. That came up about 4 times to save the day, and for sure. So how does Pythagorean theorem work? Check this out. So if I have an angle alpha, and this is the hypotenuse, hey, what is this side? This side is h sine alpha, and this side is h cosine alpha. You know what I mean? The sun is shining on the sine part, and this is the cosine part. And so if we say, or what the hell am I even getting at? I even forget what I was going. Oh yeah, just oh yeah, Pythagorean's theorem. Yeah, duh. So yeah. So we have a squared plus b squared is equal to c squared. So even we could just do it like this. You know what I mean? Hey, let's, and you don't have to. You just factor out the h. So this is where you get the unit circle of like 1 sine alpha, cosine alpha. So that is what you definitely want to do. And now you can see Pythagorean's theorem is sine squared alpha plus cosine squared alpha is equal to 1 squared, which is 1. Cool. And if you're a newbie to trigonometry, I would, anytime you see a sine squared alpha, like don't write it like that. Write it like this. Sine alpha squared. And even better, write it like this. Sine alpha, sine alpha. I don't know. You know what I mean? I wouldn't do it like that, but maybe like this. And then write Pythagorean's theorem is sine alpha squared plus cosine alpha squared is equal to 1 squared. You know what I mean? I think visually it's going to be, I did it this way for quite a while. You know what I mean? Especially when I would get hung up on like, what does that mean right there? The 2 right in the middle. Because sometimes you just, you know what I mean? And I don't know, now that I'm kind of teaching this stuff, I'll probably never forget. But no, I probably will. I mean, you don't do this stuff for a few years, and you go back and you're like, what? What does that mean again? So anyway, so here's a foolproof way to kind of understand what the hell's happening with that sine squared and cosine squared. All right, that's Pythagorean theorem. That's a good place to end. And thanks for joining me. And guess what? That's a video.